Hi. Now we are going to talk about basic formulae in chapter electrostatics and related problems. Part 1, electrostatics, basic formulae and problems. First part. Already we have seen the theory of electrostatics. So now we are going to see only the formulas and basic problems related to that particular formulas. Total charge Q is equal to Ne, where N is the number of electrons and E is the charge of an electron, whose value is 1.6 into 10 power minus 19 coulombs. Coulomb's law. Coulomb's law, the force of attraction or repulsion between 2 point charges is given by Coulomb's law. Air medium 1 by 4 pi epsilon naught Q1 Q2 by R square. Denser medium is not air medium, it is denser medium. In that case, it is 1 by 4 pi epsilon Q1 Q2 by R square. Epsilon is equal to epsilon naught epsilon R. Epsilon naught is permittivity of free space or air. It is a constant value, 8.854 into 10 power minus 12. Unit wise, epsilon naught you take it here, a force you take it here, Q1 Q2 by Fr square. So unit should be Coulomb square by Newton meter square. Coulomb square by Newton meter square. Actually, when you substitute the value of 8.854 into 10 power minus 12 in denominator, multiply by 4 pi, and then calculate the total value, it is 9 into 10 power 9. 9 into 10 power 9. Problems will be very useful because every time we need not substitute this value and then rearrange the concept. 1 by 4 pi epsilon naught, directly we can write as 9 into 10 power 9. Okay, fine. Next, electric field. Electric field basic formula E is equal to F by Q naught. F is the force between the two charges. Q naught is called test charge. Q naught is called test charge. Here Q1, Q2 are two charges separated by a distance. Both are positive. This is the formula. Of course, two positive charges means it will repel, one plus, one minus attraction. In that case, you will get a negative sign here. You can write in vector form also. So electric field will be force between the two charges divided by the test charge Q naught. Electric field due to a point charge. One charge is Q coulomb, another charge is 1 coulomb. Q coulomb and 1 coulomb. E will be Q by 4 pi epsilon naught R square. Force is Q1 into Q2 by 4 pi epsilon naught R square. Here two charges is, one charge is Q, another charge is 1. So Q into 1 by 4 pi epsilon naught R square by test charge is 1 coulomb. So only point charge. Electric field due to a point charge. Next, dipole moment. Dipole means two equal and opposite charges separated by a small distance. Two equal and opposite charges separated by a small distance, we call it as a dipole. So here, minus q plus q separated by a distance 2d, 2r, 2a, anything you can put. This is dipole. Dipole moment is product of magnitude of any one of the charge into distance between them. Product of magnitude of any one of the charge into distance between them. Q into d. Unit wise charge into distance. Coulomb meter. Capital C, small m. Coulomb meter. Okay. So we can say Coulomb meter in this case. So Coulomb meter is a basic formula for basic unit for your dipole moment concept. So next we are going to see electric field of a dipole along the axial line. Electric field of a dipole along axial line. E axial. The basic formula for this is 2p by 4 pi epsilon naught r cube, where p is called dipole moment, q into 2d. Here, r is very much greater than d. 2d is the distance between the two charges. So compared to the total distance r from the center point where you are going to calculate the electric field, this d is very small. So we are neglecting. The final formula is 2p by 4 pi epsilon naught r cube. For equatorial line, electric field of a dipole for a equatorial line, E equatorial is equal to P by 4 pi epsilon naught R cube. P by 4 pi epsilon naught R. So half of this line. Okay. Next, torque experienced by a dipole placed in uniform electric field. You are placing a dipole in external electric field. It experiences a torque. That torque formula Pe sin theta. It is a vector product P vector cross E vector. Cos theta means scalar product. Sin theta means vector product of two vectors. Okay. Next. Electric flux. Number of electric lines passing through a given area. We call it as electric flux. That is phi is equal to closed integral E vector dot dA vector. dA vector you can write or ds vector you can write, anything you can do. Surface area, normal of the area. This is electric field dot product. So it should be EdA cos theta. If you take ds, means EdS cos theta. Vector product of two vectors. This resultant electric flux is a scalar quantity. Okay, fine. Next. Gauss law. In the case of Gauss law, the electric flux phi is equal to 1 by epsilon naught times the total charge present. Charge enclosed in a Gaussian surface. Maybe a wire, or it may be a sheet, or it may be a spherical shell, or it may be a sphere, anything. You are considering a portion. Surrounding that one, we call it as Gaussian surface. The charge enclosed in it, we call it as Q. Then the number of electric lines passing through will be 1 by epsilon naught times the total charge present in it. Three applications we have in Gauss law. Electric field due to a wire. Electric field at a point due to a single plane sheet. Electric field due to two sheets. Electric field due to spherical shell. Wire, sheet and spherical shell. Sheet we have two cases. Spherical shell we have three cases. Single sheet, double sheet. Double sheet we have two cases. Before that, some basic information. Linear charge density, lambda. Surface charge density, sigma. Volume charge density, rho. Charge by length is lambda. Charge by area is sigma. Charge by volume. Charge per unit length. Charge per unit area. Charge per unit volume. Okay. So for two sheets, single sheet, two sheets. First wire formula we will write lambda by 2 pi epsilon naught r. Infinitely long charged wire. Electric field at a point outside is given by the formula E is equal to lambda by 2 pi epsilon naught r. For a single charged sheet, sigma by 2 epsilon naught. You know lambda is Q by L. You know sigma is Q by A. Now you have two sheets. You have two sheets. One is plus sigma, another is minus sigma. So next question will arise. You are considering a point in between the two sheets, or you are considering a point outside. In between P, outside P dash. In between means electric field inside or in between. Sigma by 2 epsilon naught plus sigma by 2 epsilon naught, that is sigma by epsilon naught. Whereas for two sheets, point lying outside, sigma by 2 epsilon naught minus sigma by 2 epsilon naught you will get. So the answer is 0. The answer is 0. Electric field due to a charged spherical shell. Charged spherical shell means it is charged spherical shell. Shell means hollow, having a charge plus Q. Electric field lines pointing outwards. You can consider any point outside. You can consider the point lying on the sphere. You can consider the point lying inside the sphere. 3 cases. Outside, on the sphere, inside the sphere. Q by 4 pi epsilon naught r square, where r is greater than capital R. Capital R is the radius of the spherical shell. You are considering one point outside, so definitely R should be greater than R. Same capital R is replaced by small r is replaced by capital R. Q by 4 pi epsilon naught capital R square, point lying on the sphere. Point lying inside. Inside the sphere, if you consider it is hollow. No charge present inside. So charge inside the shell is 0, therefore electric field is 0. Okay, so these are the basic formulas in electrostatics part 1 topic. Related to that, we'll go to the problems. Okay. If a body gives out 10 power 9 electrons every second, how much time is required to get a total charge of 1 coulomb from it? Body gives 10 power 9 electrons every second. We need 1 coulomb total charge. What is the time required? Is the question. First one. So number of electrons 10 power 9. Total charge Q is equal to 1 coulomb. These are the data given. You know the basic formula, Q is equal to NE. N is 10 power 9, E is 1.6 10 power minus 19 coulomb. So Q dash, in our case Q dash, our requirement is Q 1 coulomb. So 1.6 into 10 power minus 10 coulomb is the charge present in the body. Number of electrons given, total charge present in the body. I need time taken for 1 coulomb of charge. That means time taken for 1.6 10 power minus 10 coulomb is 1 second. That is the condition given in the problem. We don't want this charge, but we want 1 coulomb charge. Therefore, T for 1 coulomb is equal to 1 by 1.6 10 power minus 10. That is simplify 6.25 into 10 power 9 seconds. 6.25 into 10 power 9 seconds. Okay. First one. Second problem. Calculate the Coulomb force between two alpha particles separated by a distance of 3.2 into 10 power minus 15 meter in air. Coulomb force basic formula you know. F is equal to Q1 Q2 by 4 pi epsilon naught R square. This is Coulomb force. Here charge given is Q1 is equal to Q2. Alpha particle is 2He4. So we have 2 protons. 2 protons means we have equal number of electrons, 2 electrons. So the charge here is 2E. 2 into 1.6 10 power minus 19 coulomb is the charge of Q1 and Q2. So formula F is equal to K Q square by 4 pi epsilon naught R square. R square is K, 9 into 10 power 9. into q square. What is q square we have done, ma? 2e. So 3.2 into 10 power minus 19 divided by force F. So force only asked here. Distance is 3.2 into 10 power minus 15 meter. 3.2 into 10 power minus 15 the whole square. K 9 into 10 power 9. Q square is 2 into 1.6. That should be 3.2 10 power minus 19 divided by r square. R is the distance that be in the alpha particle. 3.2 into 10 power minus 15 meter given. So it is, simplify this concept. You are getting the answer 90 Newton. 90 Newton is the answer. Straight problem. Straight problem. Formula is Coulomb's inverse square law. How far apart shall the two electrons be if the force each exerts on the other is equal to weight of the electron? They have not given the force, but that force is equal to weight of the electron. Weight of the electron means mass of the electron into gravity, mg. So you equate Coulomb force with the normal weight mg. F is equal to W is equal to mg. So I can write Fe is equal to Fg. Fe is Coulomb force. What is the formula? K Q1 Q2 by R square. Here mass of the electron into G. How far apart the two electrons be? That is the question. That means R we have to calculate. So R square is equal to K 9 into 10 power 9. Q1 Q2 charge of the electron. So Q1 is electron, Q2 is also electron. So 1.6 10 power minus 19 the whole square divided by what's that? Me into G. Mass of the electron 9.1 10 power minus 31 kilogram. That is a constant value. G is 9.8. Simplify this. You are getting nearly R square is 25.84. So R nearly 5 meters. 5 meter and all extraordinary high value. Extraordinary high value. Problem sake we have done.